Hello everyone, and welcome to the Mat 211 review of matrices. My name is Julia, and I work for the tutoring centers at ASU. So for our problem today, we have this matrix A and we have this matrix B, and we want to compute the following statement: 5 times the transpose of A plus the transpose of B. So let's start by breaking this down into a couple smaller problems rather than writing it all out in one statement. So let's look at 5AT, or A transpose first. And so when we're looking at a scalar multiple, which is our 5 here, just a regular real valued number, multiplied by some matrix, we can either do the scalar multiplication before or after the transpose. This is not true if you're multiplying two matrices together, but in this case, because the scalar values are only modifying the individual elements, it's not going to matter which order we do it. So let's start by taking the transpose of A. So AT. Now remember, when we take the transpose of A, we're taking each column and turning it into a row. Or you can also think of this as each row, so like this first row, becomes a column. And you do them in order. So you would do first row becomes the first column, and second row becomes the second column. Or if you were doing columns to rows, you would do the first column is the first row, and so on and so forth. So let's look at our A transpose. We have, and let's do it row wise. So we have our first row here, 2, 1, 7, and we're going to write that as our first column. 2, 1, 7. And then we'll take our second row, 1, 1, 5, and write it as our second column, 1, 1, 5. So that is our A transpose. Now we want to think about a scalar 5 times A transpose. And whenever we multiply in, just real value numbers like this, multiplied by some matrix, A transpose in this case, we're just multiplying each element component-wise by 5. So we would have 2, 1, 7 here and 1, 1, 5. And so this would equal 2 times 5 for our first element here, 1 times 5 for our second element, then 1 times 5, 1 times 5, 7 times 5, and 5 times 5. So this means we have 10, 5, 5, and another 5, 35, and 25. Great. So now that we have that, we have this whole first term already calculated. Let's look at our second term, which is the transpose of B. Just like with the transpose of A, we're going to just take the rows and make them our columns. So let's do that over here. Our B transpose, we'll take the first row and we'll make it our first column. So 3, 0, and 0. And then our second row becomes our second column, 2, 1, and 1. So now we have all the pieces, we have each of our terms calculated. So all we have to do is sum them up to calculate our full statement here. So we have 5 A transpose plus B transpose is going to equal this guy. So we have 10, 5, 5, 5, 35, and 25, plus the transpose of B, this guy, which is 3, 2, 0, 1, 0, and 1. And now it's just a matter of summing them up component-wise. Now remember really quickly, it's important to note that we can only add these if there's the same dimensions. We already know that they're going to be the same dimensions because our original B or A and B matrices were the same dimensions because we had 2 rows times 3 columns for each. And same with this one, 2 rows and 3 columns. So therefore, since we switched the rows and columns, each of these is going to be 3 rows and 2 columns. And we can see that just by looking at them too. And since our dimensions match for each of these, this is okay to do. Otherwise, if they didn't match, we would not be able to sum this up and the answer would be undefined. But in this case, we can. So let's go ahead and do it. And we're going to add these component-wise. So we'll have 10 plus 3 for our first row, first column element, and that's going to be 13. We're going to have 5 plus 2 for our first row, second column, which is 7. And then so on and so forth. We'll have 5 plus 0 is 5. We'll have 5 plus 1 is 6. 35 plus 0 is 35. And 25 plus 1 is 26. So that is our answer. This matrix right here. Yay! So, before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, please visit the Tutoring Center website, tutoring.asu.edu. Now on this page, or if you go to this full link here, you can find the tutor search tool, and the tutor search tool allows you to find tutoring services for your specific course. So thank you so much and have a great rest of your day.